Determine the convergence of 2n factorial over n factorial squared. Seeing factorial everywhere screams that we should be using ratio tests, right? So let's write down an. What's our an? What's being added up? 2n factorial over n factorial squared. Then an plus 1 simply means you're replacing n by n plus 1. And because 2 times n plus 1 is 2n plus 2, let me rewrite it in this format. Now we take the ratio test. R is limit n going to infinity of 2n plus 2 factorial divided by n plus 1 factorial squared divided by 2n factorial n factorial squared. We do keep, change, flip because you're dividing a fraction by a fraction. So you keep the very first one. You change the division to multiplication. You flip the second fraction. And now, let's write the fraction as this one times the other one, because that way it's easier to simplify. We have n factorial divided by n plus 1 factorial. This is squared. Both of them are squared, so I just put parentheses and squared the entire thing. And then you have 2n plus 2 factorial over 2n factorial. Okay. How does this one simplify? 1 over n plus 1. Right?
Okay,
This is
yeah.
n times n minus 1, so on and so on, and this is n plus 1 times n minus 1. So if you write out the factorials, you see that you have the same n factorial included in both. When you cancel them away, you get limit n going to infinity of 1 over n plus 1. Yes?
We don't have to write out work for that shortcut on an
Yeah, so you can just write here to there.
Okay.
Yeah. Without explaining it, that's fine. Okay, but what about this one? How does this simplify?
2n plus 2 times 2n plus 1.
Right. So 2n plus 2 factorial means 2n plus 2 times 2n plus 1 times 2n times 2n minus 1. Keep subtracting 1 until you reach 1, right? Bottom one is 2n times 2n minus 1. Keep subtracting 1 until you reach 1. And if you look at this part and this part, they're exactly the same, so after you cancel them away, that's what's left. So you get 2n plus 2 times 2n plus 1 over 1. Now, let's carry on the limit. We still have to take limit n to infinity. For the bottom one, n plus 1 squared is n squared plus 2n plus 1 if you expand. For the top one, if you multiply, you get 4n squared plus 6n plus 2. Okay, what's this limit? 4, because these are the dominating terms, and their ratio is just 4n squared over n squared is 4, so you get 4. Okay, therefore, what do we know?
And it's divergent.
It's divergent because this is a case when r is greater than 1, therefore summation of n equals to 1 through infinity of 2n factorial over n factorial squared diverges by what test? By
The ratio.
ratio test. Oh, and you also want to say that this is bigger than 1. That's why it diverges.